Let us start with very important concept regarding programming aspects. What is meant by a language? What is the main purpose of language? How to interact with the computer? What type of languages we have? Categories and elements. Let us start with the first point. It's a language. See, a language is nothing but language is a communicator. Language is nothing but a communication between two people. Generally, we use Telugu, English, Hindi, Malayalam, or any other. Language provides you communication between two people. If you want to interact with somebody, we require a language. If you want to share your information, you require a language. If you want to convey some information, we require a language. That means language always provides you exchange of information between the people. But the problem is, here we have a computer. Consider this is a computer. This is a computer. And here we are a user. Is it possible to communicate directly with the computer by using Telugu, English, or Hindi? No. That's why you require a programming language. Computer programming languages. We require a component, what you call a programming language. What programming language provides? A programming language provides communication between user, what you call a programmer, and the machine, what you call a computer. If you want to communicate with some person, we require a language. It may be Telugu, English, Hindi. If you want to communicate with a computer, we require a programming language. Programming language. Programming language provides communication between people. What are various programming languages? In general, we have different types of programming languages. What are they? How we can have differentiation? Say this. There are three types of languages: machine language, second one is assembly language, third one is high level language. There are three categories of programming languages. Number one, machine language. Second one is assembly language. Third one is high level language. Still we have other languages, higher level languages, object oriented languages, natural languages, etc. We'll discuss about those elements later. First, we start with these components, what you call machine language. Machine language. Second one is assembly language. Third one is high level language. Listen. A language in the terms of zeros and ones. Everything in the terms of zeros and ones. What you call, these are called as binary codes, also called as binary digits. Binary digits. So a language in the terms of zeros and ones is said to be a binary code or a binary digits or zeros and ones. This is totally a machine understandable language. Human cannot understand what the zeros and means. For example, I'm writing some program. What it contains, everything in the terms of zeros and ones. Everything in the terms of zeros and ones. See, I'm writing some instruction. 1 0 0 1 0 1 1 0 0 0 0 1 0 0 1 0. This is an instruction which means that perform addition of 1 and 2. You cannot directly understand what it means. Machine language is a machine understandable language in the terms of zeros and ones, but it can provide you high speed because a computer can understand machine language, and we are writing the programs in machine language so that no translator is needed. So it provides you high speed of execution. No translator is needed, but there is a difficulty in understanding this machine language. It is very difficult for us to read and write, execute, and debug. Remember a technical term, bug. Bug is nothing but error or a mistake, malfunction, fault, failure, problem, anything. In our program, whenever there exists an error, that error need to be identified and corrected. You need to identify error and then correct the error. This process is known as debugging. Remember these technical terms. Once if you write the program, that program need to be executed. During execution, there is a error. Error is nothing but bug. That bug need to be identified and then corrected. That process is said to be debugging. So there are three types of programming languages. Number one, machine language. What machine language? It consists of zeros and ones, what you call binary codes. Any instruction, any statement need to be written by using only zeros and ones. Second part, it is very difficult for us to read, write, execute the statements in the form of zeros and ones. For their quest, we go for another language, what you call assembly language. See, assembly language is a language, it includes some set of symbols or mnemonics. Symbols or mnemonics. Those symbols may be add, mul, div, sub, load, store, jump, etc. Multiple. Add is nothing but addition. Mul is nothing but multiplication. Div is nothing but division. Sub is nothing but subtraction. Loading, storing, jumping, etc. These are also called as mnemonics. Assembly language consists of some set of symbols for each and every machine language instruction. Those symbols also called as mnemonics. What are those symbols? Addition, add, mul, div, sub, load, etc. For example, if I write a program like this, load R1, 4, load R is nothing but a register, R2, 5, add R1, R2. That means when compared with zeros and ones, this assembly language can provide you somewhat easiness. Not that much when compared with only machine language. So again, there is a difficulty with assembly language also. For example, there is a machine dependency problem. If you write a program, for example, if you are writing program in Java, for example, if you write the program at any machine, that will be executed, that is copied, executed anywhere. But in the case of machine language or assembly language, when you write the program for one particular machine, that may not be executed or any other machine, that may not be executed on other machines. This problem is said to be machine dependency problem. So you are restricted to one particular computer. You are not supposed to execute the program on any computer. That is only the problem for invention of high-level language. So next language is high-level language. In the case of machine language, we are using zeros and ones. Assembly language, symbols. Third is English in the terms of our general English statement. For example, consider a program. This is a basic. There is a language called basic. Basic is a programming language. Let x is equal to 10. Let y is equal to 20. Compute z is equal to x plus y. We have to print it, print z value, and then end. How simple this is? Even though you don't have any kind of knowledge regarding programming, you are able to understand this program, what it means. Consider x value is equal to 10, y value is equal to 20, calculate z is equal to x plus y. That means 10 plus 20, that will be 30. 30 will be stored on z, and then we are printing z value and then stop. See, high-level language is a language that is in the terms of general English statements. That means everything in the terms of general English: read, print, get, set, if, while, whatever it is, any information in the terms of general English statements is said to be high-level language. That's why we all are using high-level languages. Some examples of high-level languages includes, see, in conventional days, we used to have, there is a language called a Pascal. It's a Pascal, Fortran, COBOL. All these are traditional programming languages like C, C++, Java, Python. These are nowadays languages. These are the olden days languages. Basic. Later we have C. So these are various high-level languages. What is high-level language? I told you, high-level language is a language that is in the terms of general English statements. What is assembly language? Assembly language consists of symbols. What is machine language? Machine language consists of binary digits, binary codes called as zeros and ones. Which one is understood by the user easily? High-level language. Which one is easily understood by the computer? Machine language. Isn't it? Right. But we have one problem, because consider this is a computer. This is a machine or a system or a computer. What computer can understand, what type of language it can understand, that is in the terms of machine language. What is machine language? Language in the terms of zeros and ones. Okay, next. Here I am writing user or a programmer writing a program in assembly language. What is assembly language? Symbols such as add, mul, div, sub, load, store, etc. See, computer can understand only machine language, but you are writing program in assembly language. What we require? We require a translator. What is that? Translator needed. What is a translator? Here, assembler. Assembler is a translator or a converter. Assembler is a translator or a converter which converts assembly language into machine language. Clearly, user or a programmer writes program in assembly language, but the machine can understand only machine language. We require a component. What is that? A translator. What is the translator? That is called as assembler. Assembler is a translator or a converter. This is a translator or converter or a program. It is a program. It is not a hardware. It is totally a program or a converter or a translator which converts assembly language into machine language. So that whenever you wrote assembly language programs, that will be converted into machine language by a translator called a assembler. One more problem. For example, if I am writing a program in high level language, what is high level language? It is in the terms of general English statements. High level language is nothing but general English statements. So whenever we have a program in the terms of English, I told you let, display, read, print, etc. All these are English statements. So we require some other translator. That translator is called a compiler. Compiler is a translator which converts. Compiler is a translator which converts high level language into machine language. Once again, compiler is a translator or a converter or a program which converts high level language into machine level language or machine language. So one translator is for assembly language to machine language. What is that? Assembler. Another translator is compiler. What is compiler? It is a translator which converts high-level language into machine language. And one more translator is there. That is interpreter. See, interpreter is also a translator which performs the same, which converts high-level language into machine language. Compiler and interpreter, both the programs, both the converters do the same thing. But difference is interpreter is going to convert high level language into machine language in a step-by-step format. In a step-by-step format. Whereas compiler, entire program will be converted at a time. See, compiler is going to convert the total program at a time into the machine language, whereas interpreter is considered, it performs a step-by-step conversion. So, once again, there are three types of programming languages: machine language, assembly language, high-level language. Machine language is in the terms of zeros and ones. Assembly language consists of mnemonics or symbols. High-level language consists of general English statements. What are the examples of high-level language? Pascal, Fortran, COBOL, BASIC, C, and so forth. Higher level languages, object-oriented languages, we have nowadays C++, Python, Java, similar, and so forth. So, for example, you are writing programs in assembly language. Good. Is it directly understood by the machine? No. So what to do? We require some kind of converter. What converter can perform? Whatever the program given by the user will be translated into required component, what you call machine language. Then what is meant by compiler? Compiler is a translator which converts high-level language into machine language. What is interpreter? Interpreter is also perform the same, but the difference exists. In the case of compiler, total program will be converted at a time. Whereas in the case of this interpreter, a step-by-step conversion will be executed. For example, some person, for example, Narendra Modi, visiting your place. He is speaking in Telugu or in Hindi or something, but those people are unable to understand. So what they require? They require a translator who knows both English and Hindi. When he gives instruction in the terms of Bayo, Baheno or something, he is going to explain, dear sisters, friends, others, listen. In a step-by-step, that is interpreter. Okay, right. And I told you one technical term, that is machine dependency. Machine dependency. I told you these two languages are machine dependent languages. What is machine dependent? I told you, if I write a program in one machine and I can execute the program in any other machine. If you copy the program into your pen drive and execute the program at any machine, no problem at all, because it's high level language. But these two components are considered. If we have one computer, if you write the program in this computer, you are supposed to execute that program only in this machine. If you are trying to execute this program in other computer, that may not be executed because it is machine dependent language. Separate codes exist for every computer. Every computer is different. If we write a program for one computer, that may not be executed for other computer. This is called a machine dependency. Whereas high-level language is concerned, you can execute anywhere. That is called as a machine independent language. What it is? High-level language is called machine independent language. Whereas machine language, and assembly languages are considered, these are machine dependent language. Is it okay? Is it okay? Next point. Move on to the next component is in the terms of I want to learn a language. How to learn a language? For example, in the case of your childhood, your parents starts with a model, what you call, they usually communicate with you in the terms of alphabets or alphabets, symbols, or sometimes sentences, words, sentences, then information. Here, I'm going to learn a specific language, what I require. I require characters, numbers, alphabets. Then I'm going to form words. Words will be connected together to form the sentences or statements. All those sentences grouped into programs. But in the case of computer languages, there are 4 steps. First one is you have to identify the first stage, analysis. Second one is algorithm. If you want to learn any programming, third one is a flowchart. Fourth one is a program. See, there are 4 steps. What is the first step? Analysis. What is the second step? Algorithm. Third step, flowchart. Fourth one, program. If you want to learn, see, program, you may write this program by using any of the languages. It may be C, C++, Java, Python, or so forth. But analysis, algorithm, flowchart is common for any language. If you understood these 3 concepts initially, you are able to write programs on your own because logic is going to be acquired. You are not supposed to by heart the programming. You're always trying to write the programs on your own. That's why I'm giving you complete and pinpoint information clearly. There are 4 steps in the case of development of programming. If you want to learn any language, if you want to develop any program, what we require? 4 phases or 4 stages: analysis, algorithm, flowchart, and program. Isn't it? Right.